In lesson 25, we're looking at monomial factoring, cancellation, and parallel lines. Our first example, we're factoring 4a x squared plus 4xy. What we have to do first is find the common factor. Well, they both have 4's, so that's definitely going to be part of our common factor. Now, only one has an a, but they both have at least one x. So we want to use the variable's smallest exponent, and only one had y, so that would not be included. So then we're factoring out or dividing out this 4x. So the 4's cancel. I'm left with an a, and one of the x's cancel here, so I have an ax when I factor the 4x out. And then the 4's cancel in the second term, the x's cancel, and I'm just left with the y. And then this is our factored binomial, where we've factored a monomial out. And we just leave our answer like that. Okay, in the second example, we're doing the same thing, looking for a common factor to factor from this binomial expression that they give us. So between 4 and 6, I would have a 2 that I could factor out. And then they each have at least one x, so I can include an x. And then they both have at least p squared, so I can include a p squared. And then they at least have 1k, so I'm just using the smallest exponent of the variable that they both have. If only one has the variable, I don't use it. Okay, so when I divide that 2xp squared k from both of these, let's see what's left, and that's what goes inside the parentheses beside that monomial that we're factoring out. So 4 divided by 2 is a 2, so I have that in there. X squared divided by x, there's still one x left. P squared divided by p squared, well, that's just a 1. And then k divided by k is also 1. So if I multiplied 1 by 2x, it's still just a 2x. Okay, the minus sign is going to stay the same because I didn't factor out a negative number. I'll simplify the 6 and the 2. That's going to leave me with a 3. Okay, the x's cancel here. Then I'll have a p squared. And then 1k is going to cancel out, but I still have 1k left. And that is what goes inside the parentheses next to the common factor that we factored out. And then we just leave our answer like that. Okay, in the third example, we're doing the same thing. We're looking for a common factor to factor from, this time, a trinomial. It needs to come from all three terms. So if it's just 2 that has it, then we don't take it out. It has to be in all three terms to factor it out. So between a 2, a 4, and a 10, I can factor a 2 because it's a common factor for all three of those numbers. Then I have x squared, an x, and an x, so I can factor out 1x, or x to the first power. Then I have a y, and a y squared. I can factor out a y from each of those. So I'm basically dividing that common factor out from each of those. So the 4 divided by 2 is 2. X squared divided by x, there'd be just one x left, or x to the first power. And then the y's would cancel to make 1. Okay, then we have a minus sign. It's going to stay the same. The 2's cancel, the x's cancel, and the y's cancel. Since they all canceled, there's just a 1 that remains, because 2 divided by 2 is 1, x divided by x is 1, and y divided by y is 1. And when I multiply all three of those 1's together, it's just a 1. Okay, then I do the same thing. 10 divided by 2 is 5, so I'm going to have 5. X divided by x is a 1, and y squared divided by y still leaves a y to the first power on top. So this is how I would read my answer: 2xy times 2x minus 1 plus 5y in parentheses. Okay, in the next example, example 4, it says to cancel if possible. What you need to keep in mind when you have a binomial over a monomial is that each of these terms has to have whatever we want to cancel out. If all three do not have the term, then we can't cancel it out. And what I see is that each of these have an x squared. So I can cancel an x squared from all three of those, and I would have, for A, I'll have a 6x plus 1 that's left. One way to help with that is to break it up into parts: 6x cubed plus x squared, and then take that common denominator and write it under each of those terms. So here you see that cancels to make 1, and then this cancels so that there's just one x left on top, and then that's our answer for A. And then on B, all three of those do not have a common factor, so we would have to leave it just like it is. Now if I broke that up into pieces, I could cancel the x squareds from only one part, but since this is all connected together, I cannot cancel those out. It just has to stay like it is. So it doesn't cancel. Alright, now our last example, they did not have an example of parallel lines with the triangles, so what I did was use the practice D, where we're just finding the M and the N. And what you want to think about is what angles are the same. I know that these two angles are the same because they're vertical angles, and then this angle and this angle would be the same because if we extended these parallel lines here, we would see that those are alternating interior angles, and the same with the next angle. It would be an alternating interior angle because those parallel lines are being cut by transversals. Alright, now we can set up ratios to find out what M is, and then also a ratio and proportion to find out what the N is. So we could use the 4 and 7. I'll find out what the M is first, so I'm going to keep the small triangle on top just because I like to write my variables on top. So 4 over 7 equals M over 6. Then I just need to multiply both sides by 6. So M equals 24 over 7. Okay, and then to find out what N equals, I'll use that same 4 and 7, but this time I'm going to write the 7 on top of the 4 because I want to write my N on top, and it's going to be N over 3, and I'll multiply 3 on both sides. So here it'll cancel just like it did with the M, so 6. And I'll have 21 over 4 equals N. So we found the M and N on practice D.